This is a video from eSkillZone. For more videos, notes, and certificate, please visit www.eskillzone.com.
A virtual private network, VPN, extends a private network across a public network and enables users to send and receive data across shared or public networks as if their computing devices were directly connected to the private network. The benefits of a VPN include increases in functionality, security, and management of the private network. It provides access to resources that are inaccessible on the public network and is typically used for telecommuting workers. Encryption is common, although not an inherent part of a VPN connection. A VPN is created by establishing a virtual point-to-point connection through the use of dedicated circuits or with tunneling protocols over existing networks. A VPN, available from the public internet, can provide some of the benefits of a wide area network. 1. From a user perspective, the resources available within the private network can be accessed remotely. Remote access. A host-to-network configuration is analogous to connecting a computer to a local area network. This type provides access to an enterprise network, such as an intranet. This may be employed for telecommuting workers who need access to private resources or to enable a mobile worker to access important tools without exposing them to the public internet. Site-to-site. A site-to-site configuration connects two networks. This configuration expands a network across geographically disparate offices or a group of offices to a data center installation. The interconnecting link may run over a dissimilar intermediate network, such as two IPv6 networks connected over an IPv4 network. Extranet-based site-to-site. In the context of site-to-site configurations, the terms intranet and extranet are used to describe two different use cases. An intranet site-to-site VPN describes a configuration where the sites connected by the VPN belong to the same organization, whereas an extranet site-to-site VPN joins sites belonging to multiple organizations. Typically, individuals interact with remote access VPNs, whereas businesses tend to make use of site-to-site connections for business-to-business, cloud computing, and branch office scenarios. Despite this, these technologies are not mutually exclusive, and, in a significantly complex business network, may be combined to enable remote access to resources located at any given site, such as an ordering system that resides in a data center. VPN systems also may be classified by: Number 1, the tunneling protocol used to tunnel the traffic. Number 2, the tunnel's termination point location, example on the customer edge or network provider edge. Number 3, the type of topology of connections, such as site-to-site or network-to-network. Number 4, the levels of security provided. Number 5, the OSI layer they present to the connecting network, such as Layer 2 circuits or Layer 3 network connectivity. Number 6, the number of simultaneous connections. Security mechanisms. VPNs cannot make online connections completely anonymous, but they can usually increase privacy and security. To prevent disclosure of private information, VPNs typically allow only authenticated remote access using tunneling protocols and encryption techniques. The VPN security model provides: Number 1, confidentiality, such that even if the network traffic is sniffed at the packet level, an attacker would see only encrypted data. Number 2, sender authentication, to prevent unauthorized users from accessing the VPN. Number 3, message integrity, to detect any instances of tampering with transmitted messages. Secure VPN protocols include the following: Internet Protocol Security, IPsec, was initially developed by the Internet Engineering Task Force, IETF, which was required in all standards-compliant implementations of IPv6 before RFC 6434 made it only a recommendation. This standards-based security protocol is also widely used with IPv4 and the Layer 2 tunneling protocol. Its design meets most security goals: availability, integrity, and confidentiality. IPsec uses encryption, encapsulating an IP packet inside an IPsec packet. Encapsulation happens at the end of the tunnel, where the original IP packet is decrypted and forwarded to its intended destination. Transport layer security, SSL, or TLS, can tunnel an entire network's traffic or secure an individual connection. A number of vendors provide remote access VPN capabilities through SSL. An SSL VPN can connect from locations where IPsec runs into trouble with network address, translation, and firewall rules. Diagram, Transport Layer Security, DTLS, used in Cisco AnyConnect VPN and in OpenConnect VPN to solve the issues SSL or TLS has with tunneling over TCP. Tunneling TCP over TCP can lead to big delays and connection aborts. Microsoft point-to-point encryption (MPPE) works with the point-to-point tunneling protocol and in several compatible implementations on other platforms. Microsoft Secure Socket Tunneling Protocol (SSTP) tunnels point-to-point protocol (PPP) or Layer 2 tunneling protocol traffic through an SSL/TLS channel. SSTP was introduced in Windows Server 2008 and in Windows Vista Service Pack 1 Multipath Virtual Private Network. Regula Systems Development Company owns the registered trademark MPVPN. Secure Shell VPN OpenSSH offers VPN tunneling distinct from port forwarding to secure remote connections to a network or to internetwork links. OpenSSH Server provides a limited number of concurrent tunnels. The VPN feature itself does not support personal authentication. WireGuard is a protocol. In 2020, WireGuard support was added to both the Linux and Android kernels, opening it up to adoption by VPN providers. By default, WireGuard utilizes Curve 25519 for key exchange and SHA-20 for encryption, but also includes the ability to pre-share a symmetric key between the client and server. IKEv2 is an acronym that stands for Internet Key Exchange Volume 2. It was created by Microsoft and Cisco and is used in conjunction with IPsec for encryption and authentication. Its primary use is in mobile devices, whether on 3G or 4G LTE networks, since it is effective at rejoining when a connection is lost. Authentication. Tunnel endpoints must be authenticated before secure VPN tunnels can be established. User-created remote access VPNs may use passwords, biometrics, two-factor authentication, or other cryptographic methods. Network-to-network tunnels often use passwords or digital certificates. They permanently store the key to allow the tunnel to establish automatically without intervention from the administrator. Tunneling protocols can operate in a point-to-point network topology that would theoretically not be considered a VPN, because a VPN, by definition, is expected to support arbitrary and changing sets of network nodes. But since most router implementations support a software-defined tunnel interface, customer-provisioned VPNs often are simply defined tunnels running conventional routing protocols. Provider-provisioned VPN building blocks. Depending on whether a provider-provisioned VPN, PPVPN, operates in Layer 2, L2, or Layer 3, L3, the building blocks described below may be L2 only, L3 only, or a combination of both. Customer C. Devices. A device that is within a customer's network and not directly connected to the service provider's network. C. Devices are not aware of the VPN. Customer edge device, CE. A device at the edge of the customer's network which provides access to the PPVPN. Sometimes it is just a demarcation point between provider and customer responsibility. Other providers allow customers to configure it. Provider edge device, PE. A device or set of devices at the edge of the provider network which connects to customer networks through CE devices and presents the provider's view of the customer site. PEs are aware of the VPNs that connect through them and maintain VPN state. Provider device, P. A device that operates inside the provider's core network and does not directly interface to any customer endpoint. It might, for example, provide routing for many provider-operated tunnels that belong to different customers' PPVPNs. While the P device is a key part of implementing PPVPNs, it is not itself VPN aware and does not maintain VPN state. Its principal role is allowing the service provider to scale its PPVPN offerings, for example, by acting as an aggregation point for multiple PEs. P2P connections in such a role often are high-capacity optical links between major locations of providers.
This is a video from eSkillZone. For more videos, notes, and certificate, please visit www.eskillzone.com.